Let's read the question. We have a circle with center O and an arc of B bending round the edge. The task is to derive the arc length formula straight from the picture, not just quote it from memory. Here is what we are given. The arc opens an angle theta at the center, the radius is r, and the arc itself has length s. And here is the task. Starting from the diagram, show why s equals r theta. So here is what we are working with, and what we need to show. Let us picture the setup. Here is the circle with center O. Two radii O and OB fan out to the rim, each of length r. Between A and B runs the minor arc, of length s, and the angle it opens at O is theta radians. Here is the key idea. Imagine swinging a radius all the way around once. A full turn is 2 pi radians, and the distance traced is the whole circumference, 2 pi r. Our arc only covers angle theta, so it is just a fraction of that full trip. The arc and the angle are the same fraction of their totals. Let's keep the diagram beside us and work it through. Step 1. The distance all the way around the circle is the circumference. So write the proportion. The arc s over the full circumference 2 pi r equals the angle theta over the full angle 2 pi. Multiply both sides by 2 pi r to get s on its own. On the right, the 2 pi on top and the 2 pi underneath cancel, and we are left with s equals r theta. Derived. The derived result, s equals r theta. The arc length is the radius times the central angle in radians. That is where the arc length formula comes from.